welcome to the kickoff our Build with AI event series. We're thrilled to have you join us virtually today. My name is Anna and I'm GDG Allen organizer. We're so excited to be launching this series, which is all about diving deep into the world of AI and using real world applications. But before we start, I'd like to mention that it's a friendly and inclusive space. We promote a warm and respectful environment for everyone. Our events are focused on learning and sharing knowledge. Please maintain a professional and friendly attitude. Negative comments, jokes, or behaviors that put others down have no place here. If something doesn't feel right, let the host know during the event or reach out to me via email. We're here to make sure everyone feels comfortable and, of course, included. This event session will be recorded. Today, we're kicking things off with a fantastic workshop led by Yacine. He'll be guiding us throughout the incremental design of LLM-powered agentic applications. In this workshop, we'll be exploring the architectures of LLM-based systems, moving from simple instruction chains to complex multi-agent frameworks. Now, without further ado, please join me in giving a warm welcome to Yacine. Yacine, you're welcome. I'll stop sharing so you can start share your screen.
Yes, sure. Well, thank you very much for the invitation. Let's start then. Today we are going to talk about LLM-powered agentic applications. So it's a lot of buzzwords in this title, but we'll try to make it simple and with incremental complexity. So let's first start by, excuse me, yeah, that's better. Let's first start by who I am. I'm a software developer since 2018. I've been in the military before and I've retrained as a developer since then. I'm very happy. I like tech, AI, software engineering, web development. Today, I'm a consultant in Strasbourg for a great and very, let's say, hands-on company that really focuses on solving a wide array of clients' problems, and we are very proud of it. It's called Reboot Conseil. We are at Strasbourg, I just said that. But yeah, I specialize in full stack development. I do mostly web applications and now agentic applications because we have found out that a lot of our clients are now requiring AI-powered features to maximize their productivity, to talk to their data, to find where they can manage waste of time, waste of money, and stuff like that. So that's for me. Now we are going to see what we are Now we are going to outline this workshop. It's going to be 5 modules, and in these modules we are going to tackle in an incremental way the subject of agentic applications. I see that there are already questions in the chat. Sorry. What kind of technical requirements related with AI do they require? You mean for the workshop? I will tackle that when I start module 1. Basically, you need Python, a way to run Python environments, but we'll talk about that in like 1 or 2 minutes. So let me just give you the outline for all the modules of the workshop. So the first one will be the basics of instrumenting LLMs with Gemini. The second one will be about calling tools with Gemini. The third one will be the react pattern, which is reasoning and acting. We will talk about that after having seen the first 2 modules. Then we are going to see the plan and execute pattern. And then we are going to see about multi-agent systems. The client requirements. Yeah, sure. The client requirements, we had several. Uh, a client wanted to be able to do customer support for an internal ticketing system. So basically, it was a bank, and in this bank, they have a lot of internal demands for IT support, and they wanted to put more automation into this because they've gathered that a lot of questions are repeated, are duplicate of other questions, and they basically wanted to implement a chatbot on top of a vectorized database that will match duplicate questions and give the same answer to all the people who ask such questions. We also have a lot of demands for requirements for reports generation in technical fields, like for cybersecurity. You know that there are many CVEs, vulnerabilities that are published every day on various panels, and some clients of us wanted us to make like automated reports, maybe automated suggestions based on what the LLM knows about the system at hand, stuff like that. And we also have a lot of optical character recognition requirements, which is basically parsing documents of all kinds. This kind of stuff. Did I answer your question, Christophe? Thank you. Okay. So now we are going to start with module 1. Oh, sorry, I did not mention the module 5 will be about. Yeah, yeah, yeah. Well, we hope that our execution is perfect, but yeah, I will talk about the difficulties of implementing such solutions during the workshop. So in module 5, we are going to talk about multi-agent systems, and yeah. So module 1. Module 1 is about instrumenting LLM basics with Gemini and LangChain, and don't worry, I will tell you all about LangChain later. But since I'm going very incrementally, the idea here is that we are going to use Gemini first as a basic user, and then we are going to use Google AI Studio, and then you are going to use LangChain with Python to do the exact same thing, but do it programmatically, so that you have a sense on how to manipulate LLMs with your code. So the first thing you need to know, and I will send you the link here, sorry, is that LangChain is a great framework for using LLMs, and it's like the basic building block, sorry, of instrumenting LLMs. And you have on top of that another framework called LangGraph, and this framework basically is a set of abstractions on top of LangChain. So think of the game of Lego. LangChain will be like the small pieces that you can build stuff with, and LangGraph will allow you to access more elaborate structures and abstractions on top of LangChain. But we will see about that in a few minutes. So now, before we attack module 2, I have divided this repository, and I will send it to you right away. I have divided this repository in 5 modules, exactly like the plan of my workshop. So I'm going to send to you right now the repository, so you can follow along with me. Some of you will not be able to follow in real time for various reasons, because they will have problems with their code or anything like that. But it's okay. You have the repo. Everything I will talk about right now, I will execute it live, but you will have the recording, and you have the repo. So actually, let's do something now. I'm gonna activate the discussions on the repo. So if you have any questions later, you can ask me a questions. You can ask me a question directly in the repo that I've shared with you. So it's okay if you don't understand everything right now, or if you're having issues running the code. Try to follow along, and if you have questions, maybe in a day or two, we can work asynchronously to answer all of your questions. So now let's start the first module. And how will it work? I've laid down all the steps in these markdowns inside each subfolder. And before starting, you need these prerequisites. You need a working Python environment, a Google account, preferably with access to Gemini, sorry, and you will need a Google Cloud project. But it's optional. You don't have to have a Google Cloud project to use Gemini programmatically. However, if you have a GCP project, you will be able to link your API key to it and have bigger rate limits and stuff like that. But it's not mandatory, it's optional. So let's start. After these prerequisites, let's let's do what the workshop says. Let's try to understand how to instrument LLMs incrementally. So let's first start to go to the Gemini app. Really, that's the most basic and simple way today of interacting with the LLM. You all know, since ChatGPT and Perplexity and now Gemini, you all know how to use an LLM. What is great? I've bought the Gemini Advanced uh, upgrade of Gemini. It allows you to create gems, which are like focused LLMs on particular subjects, which is fine. And you have also access to a lot of external applications like YouTube, Maps, Search, and so on, directly from Gemini. I don't know if the basic offer of Gemini allows you to search the web. I didn't try it, so I can't tell you that. But with the advanced offer, you can search the web. This is why I canceled my Perplexity account, because frankly, this does the job very well. So this is the most basic way of using an LLM. But if you want to go a little further, because you want to build application based on LLMs, you will want to go to Google AI Studio. Yeah, I see the question here about paid and free versions. Yes, it will work with free versions. You will just have less rate limits when using the free versions. However, please note that if you want to use agentic applications for completely free, you can do that running local LLMs like Gemma, which is another Google model which is open source. You can use it. Maybe I have it here. Let me see. Maybe I have it in my Olama. You can use Gemma. Yeah, I have it. It's very simple. I will share the link after. If I want to run Gemma, which is a local LLM, I can say the same thing, and it's running on my machine. So you can build agentic applications directly on your laptop or on your server, but you will need some processing power. You will need preferably a GPU. And if you want to build production applications, you will encounter a lot of problems. Maybe you will not have enough infrastructure resources. So my best advice, if you're starting with building agentic applications, is to use the cloud. And yes, the cloud is a paid service. So yeah, you're welcome. You're welcome. So this is for this workshop will use cloud services. You will have a free tier that will be offered by Google if you use the latest experimental models. But if you want to build agentic applications in the wild, you will need to pay at some point, whether for infrastructure if you're running locally, you pay for your laptop or for your server, or for tokens if you use cloud services. At some point, you will need to pay. That's how AI is. That's why AI is so successful in the stock market, because it brings a lot of money to the people who build it, actually. So yeah. Uh, Now I wanted to show you the Google AI Studio, and first I want to show you a feature that I really like, and I think it's very useful to use it like that. It's called structured output. Basically, let's say you are interacting with legacy systems, systems that do not know anything about AI, but only know about given payloads formatted in a certain manner. So you will want to send like JSON to these system. Well, here with the simple prompt that says, tell me about Google, I need the company description, the company symbol, the sector, and the industry. I just tell literally in natural language what I want to the LLM, and because I've enabled structured output, let's see what happens. I get a nice JSON giving me exactly what I've described in the prompt. So basically, I've asked for these properties and I have them there. Why is it great? Because it's a very, very easy way and a powerful way to get formatted data with natural language. Because if you use, for instance, JD, you asked later about paying or not paying. If you use Gemma locally, for instance, if you try to with a single prompt to get a nice output like that, maybe it will be more difficult, because I must admit Gemini 2 is kind of smart for this. It's very easy to output with natural language a nice formatted JSON. So I get this exactly like I showed you. But now let's go a little further. Now that we know how to use AI in, let's say, let's go back in Gemini, the user-facing interface. This one is more for developers. Now, let's use the terminal. Let's use the terminal to go a little further in our understanding of how to interact with LLMs. So, I have in my environment, I use Linux. I have in my environment the Gemini API key. This is why you won't see it here. But basically, if you're using it in Bash, you will just need to put your API key here and then run your curl command. So what I just did, which is prompting the Gemini model to give me a structured output to get some properties about the company Google, I will do it now with a curl call. Let's try it. So I don't know if it's in this computer that I have my Gemini API key. Let's see. And yeah, you see, it's very, very fast. I mean, I didn't wait like even 1 second. The latency is great. And frankly, I've tried a lot of AI APIs. This one really is impressive in terms of latency. If you need to process data at scale, this is great. This is great. But I will come with the rate limits later. I will talk about the rate limits later. So what do I get when I send what I want? So basically, this is my payload. I said that I send a post request. I need JSON. I'm the user, and I want the LLM to tell me about Google, blah, blah, blah. Now, this is interesting. So I asked as metadata when I send my prompt that I need a temperature of 0, a top K of 1, the max output tokens is the default one, and I said I need JSON. So I will tell about these parameters later, but these are interesting. And what I get is one response. I may have several in certain cases. And the response is the JSON I've asked for, formatted as a string. So I get the tokens I consumed. This is good for pricing. And I see that the modality here is text, which means I did not prompt the model with an image or a video, and etc., etc. Daniel asked a question about setting a specific JSON format for the output beforehand. Yes, it's possible, and we will see it right after. This is why I do it incrementally. I will show you the code you already have access to it in the repo to do it. So this is very easy, very fast to get JSON that way. So you don't even need code. I mean, you just need your curl tool to call the LLM. But of course, if you want to build more complex systems, you will use code. So what did I write here? Let me remind myself so I'm not lost. Yeah, there's a rate limit for grounding the LLM's response. And why I'm saying this is because sometimes it will give you citations because it has searched things on the web, and you will be limited with that feature. But the limits, I think I've wrote them down somewhere. Requests per minute. I think it's like 2,000 requests per minute. Yes, something like that. Sorry, I wrote it somewhere. We'll see. But you will have rate limiting. I don't want to say something that is false, but in my recollection, it's 2,000 requests per minute. But you can check later if you're not sure. So structured outputs, they're very interesting because, like I said, when you need to integrate with existing systems like CRMs and so on, you can generate them really easily. We saw how to generate them with natural language, and then Daniel asked a very nice question about how to specify the output format beforehand, because yeah, this is still a kind of random because I'm still using plain natural language. It's not as structured as I would want. So before we go with answering Daniel's questions, let's talk about the parameters I've mentioned before. The temperature, basically, for those who don't know, it's about the consistency and the deterministic aspect of the response, which is will the LLM generate the most probable response with the temperature of 0? Yes. And with the temperature of 1, it will try to be more original in a sense, because it will not use the most probable response in its output. But for production systems, for integrating with other systems, you want to use a lower temperature. And you also want to set the top K parameter to 1, because 1, it will make your generation faster, and 2, because in the same way that you want a deterministic output, you want the LLM to only consider X tokens to choose from, and this will be the less possible, the lower possible value, which will be 1. And this is why I always put in such applications a temperature of 0 and a top K of 1, because I want reproducible outputs and consistent outputs. This is why I do that. So I have another question from JD. Is it preferable to run these AI projects under Ubuntu? Frankly, I don't know, because I don't use Windows. Most of the server technologies out there are Unix, Linux-like OSs. So I tend to say, is it preferable? It's preferable to use Linux system, or at least Unix systems, because there is a wider support for these technologies than for Windows, I suppose, because I don't use Windows, so I don't know. But right now, I would say that it's better to use Linux, but maybe I'm wrong. I don't know. So now we have seen how to generate these outputs from a UI, from a developer UI. which is Google AI Studio. Where is it? It's here. Yes, from developer UI and from the terminal. And now we are going to see how to use to do all that we did from code. And to do that, you just have to follow the steps that I've done. And it's really clearly listed. I tried to be as clear as possible for those who never run an LLM with LangChain before. So let's start now. So I open a terminal within the module 1 folder, and then I create a requirements.txt file. And in this file, I will add all the Python dependencies that I need to run my code. So you will have LangChain, the core package. You will have Google Gen AI, the adapter with LangChain that goes with Google LLMs. You will have Pydantic, which is a runtime validation module that is great because it allows you to enable some kind of strong type checking in Python, which is great. And you have .env, which allow you to create env files, which are places that are not versioned. Don't put that in your Git repository. I mean the .env file. You can set key value pairs, mostly for credentials here. So I gave you an example of a .env file here. You will need to put your Google API key as a value here inside a file called .env, not .env.example, which is only here as a template. So this is, we are at the step of creating the requirements. Sorry, I've missed this step, which is creating the virtual environment, because without virtual environments, it's going to be quite difficult to run our code. So for those of you who are not used to run Python or do not have venv in their system, you will find plenty of tutorials and documentation on how to install venv, how to create a virtual environment. So it's okay if you don't know how to do it right now, because when you watch the recording or when you go to the repo and redo the steps here, it's quite easy. I mean, it's really documented over the web, so don't worry if you don't know how to do that yet. So now that we have created our requirements txt file, now that we have created our virtual environment, which will embed a version of Python here, we can now install our dependencies with this command, which is given here. So everything that we need will be installed, and everything will go. It's like the node modules for those of you who are more acquainted with Node.js. You will have all your packages here. So now I can copy my .env.example file to a .env file. I've already did it, but for you, basically, you will copy this file into a .env file, and you will fill in the values for your Gemini API key. So maybe some of you don't know how to get a Gemini API key. So let's go back to the Google AI Studio. I'll send you the link again. Let's go back to the Google AI Studio and let's try to get an API key. So basically, it's really simple. You select the account in Google that you're using. I know that I have this account that has a Google project and my API key. And from there, you will have it maybe in German or in English. You will have here the button, create an API key, and then you can copy it and use it. So it's really, really, really easy, and it's free. Like I said earlier, you have a generous free tier when you're using the Google AI Studio. So now that you have copied the .env example into a .env file, you can go with creating the actual application, and we are going to create an app.py file, and really, I try to make it as simple as possible. All you have to do is copy the code here. If you have followed all the steps I've mentioned before, it should work. So what does this code do? First, let me just select my interpreter. For this is just for my IDE. It doesn't prevent the code for run, but we will have like nice syntax highlighting and so on. So it's better like this. So what do we have here? We have our environment that we load from the .env file. We import our dependencies, and then we start to write LangChain code. So what does this thing do? You can basically templatize prompts, and you can put anything you like for your internal processes here and a variable. You can call it input. You cannot call it whatever you know, whatever you want. Sorry. So if I decided to call this X, I can call it X. I mean, you don't have to call it input. It's really the variable that will go here and that you will then pass to your model. You can name it the way you want. I like very explicit names, so input is fine with me. So you create your prompt template, you create your LLM instance. So what does that mean, creating an LLM instance? Of course, you will not run Gemini 2 on your machine. You will just create an abstraction that allows you to interact with Gemini, and you pass it exactly the same parameters that I've mentioned before, which are the temperature, the top K, and the model that I want to use. I like to use the latest stuff because I'm a geek, so I use Gemini 2. And you have this very, very important concept of a chain in LangChain. And don't worry, Daniel, I did not forget your question, but we are going to talk about the specific set of outputs right after this example. So I did not forget about this question, your question. So the chain, what is it? Why is LangChain called LangChain? It's because you are basically going to create sequences of runnable code, uh, and these sequences will produce an outcome, which is most of the time a string. But these sequences don't have to all the time use an LLM. You can combine Python native code from your application with chains. I mean, you can chain whatever your logic you want and then get an output. So here we are chaining a prompt with an instance of an LLM. And this is very interesting because today we are using Gemini 2 in the cloud, but if we use Gemma with Olama, the code will remain the same here. It's only the LLM that will change. So this is a nice way of abstracting the differences between LLM providers. And you have the prompt, you have the LLM, and then you just want to output the result as a string. So let's try it and let's see what happens. So I'm running the code, and this is what I get from my chain. I didn't ask for structured output, so I have like a plain text response here, which says what is Google, what are its focus areas, etc., etc. So why did I not get a structured output? It's because I just asked that I get the string with this class, the str output parser. I just asked to get the plain string from the LLM. This is how you get like, it's like I was talking with Gemini directly from the web UI, but I can do it with code with this manner. Okay, now I can finally answer. Yeah, sure, I can zoom on my screen. Sorry. Yeah. Maybe it's too much. Yeah, this is good. Yeah. Now I've zoomed a little. Yes. Now I can finally answer Dalil's question, and I can tell exactly beforehand what structured I put that I want before running it. So let's run this code instead. So basically, uh, we just run the code that allows us to get a plain text response from the LLM with LangChain. And now we are going to run the code that allows us to specify beforehand the kind of response, of JSON response we want with the Pydantic class. So like I said, Pydantic allows you to enable strict type checking at runtime in Python. And now we are creating like the schema of the output we want beforehand. I want an output that talks about a company description, a company symbol in the stock market, the industry, and the sector of the company. This is my schema. So I specify it beforehand. I use another prompt template, exactly like we did before with our input, but this time I will add a system prompt, and then I will talk to you about the system prompt. And like I did, I'll create an LLM with exactly the same parameters, and this time I want it with structured output. So basically, I'm using more or less the same code, but this time when I create my LLM, I explicitly say that I want it with structured output, which is a feature of LangChain that allows you with various AI providers to generate JSON beforehand by specifying the schema as a parameter. So now I have my schema. I told that my LLM is supposed to give me a company description, a company symbol, and blah, blah, blah. And now I can create my chain. I don't have to specify here for the example, but I could specify that I need JSON loads or an str output parser. I can specify the rest of the chain if I want, but here I don't want to do this. I just want you to show you, I just want to show you what's inside the result when I call the LLM with structured output like that. So what is my prompt this time? I just describe Google, and I expect the LLM to give me an output with the structure that I want in the end. So let's go. So now I've stopped here in my breakpoint. And what do I have? I have a Python object, which is a company info. You can see here. It has a company description, a company symbol, an industry, and a sector, exactly like I said. Now let's try something funny. Let's try to ask it something completely different, like the biggest yogurt company in the world. Let's see what happens. If I don't add a lot of information, let's see what happens. So what do I get here? I still have exactly the same kind of object because I've constrained the LLM to always give me company info, whatever I ask for. And I have an hallucination because I don't think this company exists. And I have the industry and I have a sector. Why did I use this example? It's because I want you to understand that you can constrain the LLM to give you formatting in the response exactly as you expect, whatever the input. So this is how you get structured output beforehand, Daniel. So now that we did that, we can go a little further. I want you to realize that at module 1, you know how to code agentic applications. You know how to call an LLM with code. You know how to get a JSON-like objects with code. You're ready. You don't need anything else, really. All the rest is like tools that maybe will make your life a little easier. But basically, that's all you need to know if you want to start with building AI applications. I don't think you need more than that. Of course, you will need abstraction for streaming, for multimodality, all that stuff. But if you want to get started with really cool applications that do a lot of stuff in a powerful way, this is the basic minimum code that you need and that you will use all the time. So yeah, you can start with these two snippets to build AI applications. Really, I mean it. So now that we have talked about structured output, plain text outputs, we are going to go with multimodal inputs. So basically, what is multimodality? You can now talk with LLM not only with code, not only with text, but with images and with your voice, with videos. Now your inputs to LLM may be comprised of various data types, which is great. So here I put an example of how to use an LLM with an image, which is now we are going to use Gemini. But if you're running Olama, I think Palygema is a vision model, but I'm not sure. But you have also other open source vision models like Llama 3.2 Vision and so on. So now we are going to use Gemini because it's a Google developer group, and I like actually this model. So we're going to use this one. So what are we going to do? We are going to parse the example image that I've put here in the repo, which is basically the Google logo, and we are going to ask the LLM what's in this image. So let's try. Let's try this. I want to run this code. So if you run it with the debugger like me, maybe you will have to put like the relative path for the image. So this is what I'm going to do. And then let's try. Let's see what happens. I put a breakpoint here. Yeah. So in the response, I do have a nice content. Let's copy it so we can see it here. So what does the LLM say? The image contains the Google logo, blah, blah, blah. So it has actually parsed the image. So again, this was really fast. I think it's why you need to realize that I've asked an AI to read an image, and I had like a very, very decent latency for this. And this is one other reason that I prefer in production application to use paid cloud services, because you will not have that kind of speed on many machines. So this is why it's useful to use the cloud as well. So with this snippet, you are now able to talk to LLMs with images. I didn't try the videos, but I guess you will have to specify another type. So yeah, let me comment the code, sorry. What I do is I use the exact same model because Gemini 2 is a vision model, so it supports images. I transform the image into a base64 string, and then I send the string as a human message, which is another abstraction of LangChain. You have to differentiate system prompts, AI prompts, system messages, AI messages, tool messages, human messages, because they're not the same. And yeah, we already tackled system prompts before. I did not expand on this. Here, when we tried to get structured output, we used a system prompt. For those of you who don't know what that is, a system prompt is basically a prompt that will be injected before the conversation, that in which you want to set like behavioral guidelines for the LLM. So you have also, on top of system message, a human message, which is basically the message that the end user will have when interacting with the LLM. So when I want to do multimodal multimodal inputs, I want to specify the prompt, which is always a text, and I want to specify the data, which is of type X. In this instance, it's an image, and I pass it as a base64 encoded string and some metadata before the base64 encoded string. And I only have to do that to describe an image with LangChain, which I think is great. Now that we have seen multimodal inputs, sorry, let's try something even more interesting. The same thing that we did before, which is getting a structured output, but this time with an image. And as I can already envision, and I'm sure you do, all the things you can do with this feature. Basically, let's say you are creating a factory management system. You can create structured outputs with pictures of what's happening at your factory at an instant t, which is great because you can interact with legacy systems that way. You take a picture of something, you get a JSON, and you do something with that JSON. That's really, really cool. Even with documents, with everything that can be parsed by Gemini to Vision. Let's try to do the same thing than before, but this time let's ask it to give me a structured output. What is going to happen? Let's go. I run the code. And yeah, sorry, I did forget to put the relative path of the image since I'm using the debugger. Maybe you will have the same problem. Sorry about that. Okay, let's go. So what do I get here? My company info object with the ticker symbol of Google, the industry, the sector, etc. So that works. That works. I can get structured output from images with Gemini. So now let's summarize what we've done so far. We have interacted with an LLM like every 1 billion and so on, 2 billion users using. When will the agentic part start? I think it will start at module 2 or 3. Module 2, we will use tools, so it's kind of agentic. And then we will attack module 3, which will talk about the React pattern, and we are going into the more agentic stuff. But yeah, this is why I've did this in purpose. I want to tackle the agentic part in a very, very incremental way, because when I've learned agentic applications like 1 or 2 years ago, it was really difficult because a lot of new abstractions, a lot of new concepts. And now if I had to relearn it again, yeah, exactly. The basics are important. Now, if I had to relearn the whole thing again, I think I would focus on the very basic parts: how to call an LLM with code, how to generate structured outputs, how to accept various modalities. Like I said, and I'm really convinced of this, you don't need much more than that to build agentic applications. The rest is really like um, not optional, but it will help you. But if you're using plain applications, you don't have to install a lot of stuff to build a really cool logic with AI. So now we are going to talk, now that we have multimodal text, structured outputs, and etc. Now we are going to talk about batching calls. This is important in production applications because oftentimes you will have to process various inputs at a time, and you can do that with LangChain very easily by using with the chain abstraction, by using the batch method, which allow you to pass several prompts at a time. And again, I'm impressed by the latency of Gemini on this one. So let's try it. So basically, it's the same code than before. We generate the same LLM. We have our prompt template. We have a chain that is supposed to render a string, but we can also use structured outputs. And we have like different inputs. You can have 1, 2, 3, 100. Who cares? And what this does is that you can parallelize I/O with LLMs, which is cool. So let's go. So the latency that you see here is not because of the Gemini API. I don't think it's because of that. It's just the debugger that it's so slow. So I have a list with strings which are the responses. And now I'm curious. I want to see if the latency is really that slow or not, because in my recollection, it was much faster. So let's try it. I will try it from the terminal without using the debugger, just to make sure, just to have a better idea of the latency, because now I'm not very sure of myself. So let's go. So I'm running code. I have two inputs. I don't have images. Yeah, that's okay. That's okay. I don't know. We should compare with other providers, but we don't have time for this because we have a lot of ground to cover during this workshop. So that's it for module 1. So we have a way of batching LLM calls, sending images, getting plain text, getting structured outputs. And yeah, one last example, same thing, but with structured outputs. Let's try it just for the sake of it, because otherwise we would not complete module 1 as expected. And yeah, this time it was, I think, faster. We have the two company info objects, one for Google, one for Apple, I think. And yeah, we have the same way of batching prompts to get JSON this time. So these are trivial examples, but when applied with a lot of data and a lot of modalities, it can be really interesting to use these features for your use case. Yeah, exactly. It's very slow. Uh, thank Alexi. So now we are going to pass to module 2, which is about using tools. So I think I've prepared slide for this. Yeah. So what's the idea of using tools with LLMs? You want to extend LLMs capabilities by connecting them to external APIs, and basically uh, with ancient system that predate AI and so on, you can have an interoperability with tools that you can build so that the LLMs adapt to your APIs. So what do I mean by that? You can access information, searching the web, querying databases, browsing specific websites, make RPC calls to other systems. You can control devices for those of you who are into IoT or DIY systems. You can send emails, you can schedule events, you can do a lot of stuff, and you can, and this is why I said that the agentic stuff starts a little. You can also perform more complex stuff and chain complex operations together by using those tools. So basically, a tool is a way of giving the LLM things that it doesn't support natively, and these things can be anything that you can code. So let's go with the using tools part of the workshop. Exact same steps than before. We want to create a requirements file. We want to copy the .env into our subfolder. I've decided to use subfolders because it's way easier to manage. So we are going to keep working that way. So you need your dependencies, same dependencies than before. You need to activate your virtual environment within the subfolder that you're using, which is the subfolder 2. Let me deactivate the previous one. Up. And now I generate a new one into folder 2. And then we install the requirements. We create our app script, and we should be ready to start module 2. So let's go. Now, what are we going to do in this module? We are going to create mock tools. These are not real tools. These do not talk to a real API or to a real database. I just want to illustrate the concept of tools. So these are mock tools. Let me explain. Let me just copy the code and then run it and then explain what's happening. So let's go to the app file of module 2 and see what happens. So I load my environment, I load my dependencies, I create my LLM, and so on. You already know that. Now, this is the interesting part. In my imports, I import the tool helper, the tool decorator, sorry, so that I can specify that certain functions in my code are actually tools. So this tool will allow me to get, you have in many financial websites, let's say stock analysis, you have like the top losers, the top gainers. This is something a lot of stock market program web apps give you. Yahoo Finance does that. I think Google Finance does that also. I don't know. Let me check. Yeah, we have, yeah, the gainers and the losers. Yeah, they all do that. So basically, this tool allows you to get this list of top losers and top gainers from the stock market. This is the mock tool, and I specify it in the return value, which is a plain string. This is a mock result, and I give the LLM like the right to make hallucinations because I tell it that this is not a relevant result. This is a mock environment, so it's okay. Don't worry about it. So in the real world, this tool will actually call an API to get the top gainers and losers. I've also added a second tool, which is basically, you will have in a lot of firms some ML pipelines that will try to predict the value of data, of tabular data using LSTMs of stuff like that. And you can pass it to this function a string, and it's supposed to return a value in dollars, which is in this case will be a random integer, so we don't care about. So these are mock functions that are designed to show you how to use tools with LLMs. So now that you have tool A, tool B, you need to put them in a list, and very simply, you can bind them to the LLM you created just before here. You can say that, hey, LLM, you have a tool belt now. You are able to use this code whenever you want. And one thing that is really important when you design tools with LangChain is the doc block. It must be very, very descriptive so that the LLM understands what the function does. Basically, this doc block is not very good actually because it doesn't tell what the parameter is. So actually, make it more like a standard Python doc block. Sorry about that. Yeah, because like I just realized that my doc block was not very, very standard. Yeah, this is way better because you have like the parameter that you need, the return value that you need, and what the function does. When you create tools with LangChain, I will do it here as well because, yeah, let's correct our mistakes, make it more standard in terms of Python doc blocks. Yeah, when you create tools with LLMs, you need to be you need to be very explicit in the doc blocks because this is like the identity card of the function that the LLM will use. So be especially mindful of putting great doc blocks here. So now that you bound tools with your LLM, you can call it. I've created 3 examples here just to show you that in each case, it will call the correct tool. So you have an example where it will need to call the top gainers and losers function. Another example where it will need to call the price forecasting method. And another example, well, where it will just say hello. So it should not call any of these tools. So let's try it. Let's put breakpoints here, here, and here. And let's go. So first response, what do we get? We have, see here, the tool calls. The tool calls is like a signature of what you need to call in your code to get the response. Let me explain. This, when I invoke my text models with tools, this will not actually call the tool. This will just give me a signature. It will tell me, hey, developer, you will need to call your function called get top gainers and loser with 0 arguments, and this will have an ID in the conversation, but it will not call the function. You need to understand that. Let's see what it prints. So what it prints is the tool call here. This is the last message we get, but we don't have anything else because we did not implement the agentic flow of calling the tools, getting the result of the tool, and then getting back to the user a formatted response. What I need you to understand here is that it's not just because I define tools and bound them to an LLM that it will automatically execute the code of these tools. It will just give me a signature of what I need to use later in my code to provide the final response to the user. So I know that I need to call this function, but it's not actually calling it. So this is why we do it incrementally, because it's very important to wrap your head around this concept before going further with using tools with LLM. So now for the result 2, I should have a tool call array as well. This time it's different. This time it tells me that we will call forecast stock price with the symbol corresponding to Google. Why this time do I have an argument? It's because in my definition of the tool, I have this symbol parameter that is specified here, and also in the doc block that I've mentioned before. So let's see what it prints. And yeah, I do have, again, the last message is a tool call with the name of the tool, yes, here, and the argument that I need. Now, what happens when I just say hello to the model, even though I've bound tools to it? Let's see. Tool calls is empty. Yeah, of course, because I don't need anything. I didn't ask for forecast of price. I didn't ask for the top gainers and losers. So the LLM just answers to me like it's supposed to. So I have an empty array as a tool call, and it's perfectly normal. And I do have like a standard response from any LLM. How can I help you today? Okay, great. So this is the first step of calling tools is defining the tools, binding them to the model, and then as an answer, you get a signature. Okay, dear developer, you will need to call X, you will need to call Y with argument ABC if required. But of course, you will see that it's not super useful. It's not super useful because you want to call these tools to do something with it. And I see that Alexi has issues with his Google Cloud credentials. Yeah, maybe later you can message me, you can DM me, or in the repo that I've shared, and I'm resharing it. You can open a thread in the discussions tab, and we can see about that later. Like I said, it's okay if you have issues running the code right now. I will be able to help you later if you need. Just try to follow along, and if you have any issues, we can work this out asynchronously. You're welcome. So now you have a way of getting the signatures of the tools you are going to use in your application, but you're not actually calling them, which is a problem, because why defining tools if not using them, right? So now I will show you how to actually use the tools. So we have this example here. I'm going to just remove the example. And sorry, I will just keep result 2 for the example. And sorry, I'm going to drink water because I talk a lot. Just give me 1 second. Now, we are able to call our tool here. Let me tell you what happens once we bound the LLM with tools. We can invoke it exactly like we did before with the user question. Now I'm gonna trigger the forecasting tool here. And how does this work? Remember the previous output we have in the response when we call a tool, we have like an array of tool calls. Tool calls is always an array, even though you are calling just one tool. And an array of tool calls contain a tool call object, which contains a name and some arguments mostly. So when you are using tools in your LangChain application, basically all you need to do is looping through a series of tool calls and mapping them kind of in a dictionary-like structure, mapping them so you know how to invoke them programmatically. So basically, you will need the top gainers and loser, the forecast stock price, and with this ticked object, you can, it's like dynamic programming, you can invoke them dynamically. Of course, if you forget one of them, or if you add a non-existing tool here, maybe you will run into problems, but you shouldn't. If you lowercase everything and reference the right functions, you can invoke tools dynamically this way. So let's try it. Let's put the debugger here. And then here, what do you have? You have the result of the tool call, which is a tool message. And let me show you. Yeah, you see here, the instance of this is a tool message, and the content is this number that is generated randomly prefixed with $. And what's interesting is that before that, let's see what's in the tool call. We don't have access here to the parameter, so I'm going to rerun the code, sorry, so we can see the 2 steps. Sorry about that. So the first thing we get is a tool call with the parameter that I need, which is the symbol Google. As you can see, I need the symbol here, and the LLM figured that it needs to use the correct parameter as a string here. So it's cool. And now I'm just going to get the result of this tool call because I've implemented, me, the developer of this application, the fact that we need to call this tool. Again, it will not be called automatically. So when I call it, I have a value. So yeah, I should have bought Google stocks earlier because now it's very, very high. But yeah, it's a random number. And I get the result of my function that prefixes a random integer with $. Here. So now I can do something with the result of this tool call, which is great. So now what I want to do, and in this example, I want to reuse the output of the tool call and then give a final answer to the user, because you will agree with me here that just having a value, a plain value like that is not really helpful in a conversation with back and forth with the model. So now I'm gonna just be able to do the complete sequence. Let me just copy this and then explain. The complete sequence, which is I define my tools, I bind them to the LLM, I call the LLM with the human message, which is basically my user message. And then, if there are any tool calls, I invoke these tools programmatically, and then append the results of these tool calls to the messages of all the conversation. And finally, I call the model with all the conversation. So let's put a breakpoint here so you get a better idea of what's happening. So I have messages here, and I put a breakpoint here. You will understand better. So now this variable does not exist. It's a list of human message. It has just an item. It is initialized with the input of the user. And after I've called the model with this message, which is the human message, I should have more things within my messages variable. I have an AI message. And now, once I've called the tool, what do I have in my messages? Same thing, AI messages. But after that, I will get a tool message. So messages now contains a tool message with the value of the function, which is my custom code. And now the result will be the final answer to the user. And if I go here, do I see the whole messages? Sorry. Let's print it. It's going to be easier. So the final answer, I have it here with the content. The forecasted stock price for Google is blah, blah, blah. And I see the tokens that I've consumed. But before that, I had to put three messages in the conversation. My initial input, an AI message that knows that that we need to call a tool, and the result of the tool message call. And then I send the three messages to the LLM to get a final response. So you think you are going to have a back and forth conversation with one message and one message in return, but in fact, you are sending three messages to get one output message, which is input, tool calls, result of the tool call, and then final output. So you can basically double the number of messages required when you use tools, because that's how it works with LangChain. So I think I've finished module 2. Yes. Before we pass on to module, sorry, let me just shut down my WhatsApp. Okay, now we're gonna be it's gonna be quieter. So before we go on with module 3, we've covered a lot of stuff already, even if it's basic. And I was about to ask, does anyone have a question about tools? And yes, Christophe, is the tool functionality widely used in production? Yes, this is why most companies use LLMs in productions. It's because they need to interact with their legacy systems, and this interaction will be coded with these tools. Because if you use an old Oracle database or an old system, you will not have out of the box all that you need to interact programmatically with it using LangChain. You will have to code your own tools and then bind them to the LLM to be able to talk to your systems in prod. So yes, tools are the reason why we use LLMs in prod, because without that, you couldn't do much stuff beside asking a basic question. You couldn't create agentic application without the tools. I hope I answered your question. Yes, some people, the opinion are really mixed. I know, because like I said at the beginning of the workshop, the LLMs, they provide you with random results, unpredictable results, even if you set temperature to 0, top K to 1, even if you create your format before getting the response, you can have variable and random results. There's a inherent risk of using LLMs, but if you put safeguards, validations at the right place in your system, you can also gain a lot of productivity with these tools. I have a simple example. Imagine that you have an applicant tracking system for job applications. With a tool, you can process a lot more data than a human can, and this is useful. This is useful. Of course, there will be mistakes, there will be bugs, but this is why developers are still important today, is to put safeguards when calling these tools. So now that we are done with the tools, we are going to move to the React pattern. And I think I've created slides for this. And yeah, so basically we are going to create this very, very basic workflow that you see in the right. We are going to talk to the agent. We call it assistant here. The assistant, like we shown before, will decide to call tools or not. If it calls tools, it will give the output back to the assistant and then answer to the user exactly like we did in the module 2 before. But remember, in module 2, if I go back to our application of module 2, we didn't use LangGraph, right? We just used plain LangChain classes, abstractions, and we used a plain chain. We just invoked the LLM with messages in a very sequential way. This is not dynamic. It goes one way. It's like an arrow. It starts with this message. It finishes with this, and that's it. It's not an acyclic graph. You can go back again to the same point. It's really sequential. It's a one-shot script. But with LangGraph, what we just did now with LangChain, we can do it forever in a loop, like in a chatbot, for instance. And this is why LangGraph is powerful, and I will tell you about this in a few minutes. So first, let's rewind on what we are about to build. Same thing, but this time using LangGraph, and you will see why it's different. So what is React pattern? React is reasoning and acting. It's an acronym. And basically, how will this work? The LLM will analyze the input. Do I need a tool? Yes or no? Do I use it? Then what do I do with the tool? And then I answer. This is one turn of a conversation, but with the React agent, you can have like many of them. So this is only one slide. That's great. I don't like slides very much. So let's go with starting with our module 3. So again, this is what we are going to build, but this time with LangGraph. Same thing than before. We've added a little dependency here in our requirement.txt. Let's go. And we are going to add an app.py. And in our app.py, we are going to use our first snippet. And then I'll talk about it. Once I've created my app.py, I will need, sorry, forgot some steps, to create my virtual environment in folder 3. I do it in a repetitive manner. This is purposefully because it's when you repeat stuff that you learn them. And I think, again, it's easier to focus on the subfolder at hand, and it removes frictions if you use the same environment from the root folder, because in other workshops I had problems because of that. So I prefer repeating the whole steps again. So now I install my dependencies, sorry, and I select my interpreter, and we should be ready to go. Okay, so did I forget anything? No, I have my .env here. So that's great. I'm ready to explain the code that I've just pasted here. So what is this thing doing? Exactly the same thing as before. This time I've changed the top gainers and losers tool a little. I've added an array of gainers and an array of losers. And I also, no, the tool for the forecasting of the stock price is the same. And yeah, let's do the same nice doc block that I did before, and I lost it. Where is it? It's okay. Yeah, but we saw that this works, so this won't be a problem. But yeah, reminder, be extra careful with the doc blocks because they're important. So same thing than before. We bind the model with the tools. I just changed the tool a little, so no surprises here. Let's go on. Now I'm gonna use the first abstraction that we are going to use from LangGraph, which is messages state. So let's update the imports here. And I'm gonna use the system message, the system prompt, and this thing. So what is messages state? It's basically an array, an object that will hold all the messages of a conversation. This is the first abstraction of LangGraph that we are going to see here. I'm just going to copy the code and then explain. So we have a system prompt that gives a personality to the bot. It says that it is an investment analyst. It is equipped with tools, stock price forecasting, getting top gainers and losers. And I've created this first node of our LangGraph graph that takes in a messages state, which is basically an object that holds all the messages of the conversation. And what this thing does every time it is called, it returns the list of messages prefixed with the system prompt. So why do we do that? It's because we want to update our messages list at each conversation turn. This is why we prepend the system message every time. And when we do that, behind the scenes, if you go to messages state, this will use this little helper function. It will not overwrite the messages list. It will just concatenate messages. So you're not actually overwriting the list of messages at each turn of the conversation. You're adding them, you're concatenating them in the list of the conversation. So basically, this is our memory of the conversation. It's the state, the message state, and this agent will always return new messages with the invocation of the model, with the system prompt, and the previous messages that happened in the conversation. I don't know if that's clear. You just need to understand that every time we will feed the state with the new evocation of the LLM and the system prompt. That's it. So now that we have created this agent node, we can use more abstractions from, okay, Alexi, more or less clear. I think this deserves, even for me, this deserves another explanation. I just realized that I was not very clear. This is the first node of our graph. A node is In every graph-like structure, you will have nodes and edges that allow these nodes to communicate. The first node of our graph is our agent, is the LLM, the thing that will face the user and talk to it. This thing will return a new message every time it is invoked, and it will save these messages in a messages state, and it will not overwrite, it will not delete the previous messages, it will just add the new message to it. Exactly, states will not be overwritten, they will be concatenated. You will see the values added one after the other instead of being completely overwritten at each interaction. Is that clear, Alexi? Sorry about my English sometimes kind of sucks. So yeah, that's why my explanation was not very clear. So now that we have that out of the way, let's use other abstractions from LangGraph. And the one that we'll be using are state graph, start, tool nodes, tool condition. What are these? Let's see right now. Basically, we are going to build our graph. I've just had to design the first node of the graph by myself, because the other node of my graph, the one that you see here, sorry, the one that you see here, it is this thing called tools condition. Okay, sorry, it is this thing called tool node. So I had to write this one because I want to specify that I invoke my LLM with the system message every time. But this one is a built-in LangGraph node. It's the node that gives access to the tools. So how does this work? We create a state graph that takes a graph that takes a state, and this state is the message state. We define our nodes, which are our main constituents of the graph. We will have an agent, we will have our tools. We tell where the graph will start. It will start at the agent node, exactly as you can see here. It will start, the first node that will be called will be the agent. And then we add a conditional edge. This is why we have like this dashed line here. The conditional edge says that if there is a tool call, and we have seen that we have tool calls sometimes when it is required by the LLM, if we have tool calls, then we direct the flow of the graph to the tool nodes that contains all of our tools. And then we define the latest edge, which is from tools to agents. Why is it important? Because otherwise, we will just have the raw output of the tools, and that's not what we want. Then we actually tell that the tools will go back to the agent, and the agent will decide at this point, do I need to do another tool call, or a tool call, sorry, do I need to do another tool call, or can I directly answer to the user? And this is a very basic implementation of React, because when it receives the tool output again, it can decide to call another tool or not. And this is why it's a very powerful pattern, because this very simple graph allows you to do a lot of stuff. If you have like 3 or 5 tools bound to an LLM, it can decide to go further based on the user input or directly answer as needed. And this is why it's really cool, because with the very few lines of code, I have less than 100 lines of code, I can put together a quite powerful logic. So let's see what happens. I think after we have compiled the graph, we are about to use it. Yes, sorry. Yes, let's run it here. So I'm gonna run it with the human message. We've already seen the human messages, and we are going to just try the first example. So what do I do here? I invoke my graph exactly the same way than before, but this time I pass it a config object. This config object, if you have a lot of users, will allow you to add additional metadata to your interaction with the graph. For instance, the thread ID. The thread ID is like the conversation ID that you're having with the graph. A state graph will keep the state alive as long as the script is running. So that means if you're in Jupyter Notebook, for instance, stuff like that, if you use the same graph again and again, it will have in its context, the whole array of messages that you had with it before. And if you specify a thread ID, you can make a logical separation between conversation with this ID. So actually, let's use the 3 examples that I've prepared, and let's explain at each step. So each of these each of these interactions is a separate conversation. It's not the same conversation for the graph, because I've used every time a different thread ID. So when I talk to the LLM here, it will not know that I had sent this message before. This is why I specified it here, and we will do the inverse on the next step, which is using the same thread ID, and you will see why we did that. So I have a question. Is the graph implementation the most widely used? Is there any other method to implement React pattern? Yes, there is another method which is very, very simple, and I use it later. But I wanted you to understand how this pattern works by coding it ourselves. Basically, you have a pre-built function which is create React agent, and you can do this by just calling a method, but we will see that in the next module. But why I did implement the graph that way is that I wanted to decompose how it works so you guys can understand exactly what it does and why is it called React, because it is bound to tools and it can reason before calling tools or answering to the user. This is why it's called React. And you have several implementations of the React pattern. This is not the only one, but this one is one of the simplest I could think of because it's a workshop. And yeah, that's why I used very basic examples. I hope I answered your question, Christophe. I don't know, maybe... Did I answer your question, actually? Okay, great. So now we are going to call our graph with our examples, and let's see what happens. So the first result, what do we get? We get, as you can see, because we've configured our agent node to return a list of messages, we get a much cleaner result than before, because we get only what we specifically ask for, which is the list of messages. I could return something else here in our agent node. I would have something else. I have complete control of what I want to return at each step. So now we have the list of messages, and you can see when I ask to forecast the stock price for Google, I get the first input. I think it's way more readable than before, sorry. I have the AI message, which is a function call, same thing than a tool call. I have the tool message, which is the result of the function call. And you can see this time I did not have to code myself the fact that we need to call tools programmatically, because the object of LangGraph that I'm using, which is the tool node, does it for us. I did not have to explicitly write the code that tells my application to run the tools, because the tool node does it for us. And I have the tool message, and in the end, the AI message that gives me the final answers the final answer, which is, let's copy it so we can have a better view. The final answer, which is, these are the top gainers and these are the top losers, in a nicely human readable response. Because if you remember, I get an object like response here, but the LLM still sends me back a plain string response because that's its job. So this is the first example of a series of interaction that leads us to call a tool, but we will have basically the same thing here um, with the forecasted stock price for Google, same kind of messages array, human message, AI message, tool message, and the final response, which gives me the value that has been outputted by the function. And now let's see the same example that we've used before, the hello example, and see what we get as a message. We only get the first input and the AI input. No tools called, because at the moment of the interaction, the LLM did not decide to call tools because it didn't need to. So this is why you can have a sense of how it's powerful. You can have like a menu of tools and you decide to take them or not. So this is very dynamic, and this is why I like this pattern, because it's simple, yet you can do a lot of stuff with it. So now you remember we used a thread ID here, which is that each of our interactions were separate. Now let's see what happens if we are in the flow of a conversation and that we may want to call several tools in the same conversation. So for this, I've slightly modified our tools. So let's put them, let's update our code. What did I do? I forgot already. Let me check. This time, yeah, the top gainers and losers function will return the terrible news of the death of Tim Cook and the loss of value for Apple. It's a scenario. It's a theoretical scenario where we have a CEO of a big company that dies and the stock price falls, and it has this price. And then we have the same tool than before, which will take the initial price and then add it a random integer, which supposes that the stock price will grow up in the near future. So now with these tools, we can again call our model. And I also changed the system message. Let me show you how. Where did I put the system message? Here. This time, I've added this line here. I specify to the LLM that I'm running in a test environment, and that the LLM can feel free to give me advice on market investments, because otherwise it may tell me that it cannot do that. So now I'm specifying explicitly that it is a testing environment, so we can demonstrate the following. I see that there is a long question. I will get to that question right after having run this example. So let's go with our new series of inputs. This time, no thread ID. This means we are using the same conversation. The same state of messages will be passed to the LLM at each interaction. So these are not separate interactions. The first question that I will be asking is, who are the top gainers and losers? The response that I will have is that Apple lost 25% of this value. And then I will ask for the stock price for the forecasted stock price for Apple. And then I will ask the bot for a more for an advice about, is it a good investment opportunity, just to illustrate that the same conversation can call several tools. So let's go. And then we are going to, and then I'm going to check JD's GD question just right after that. So Let's run this. So again, I do have my AI message and the fact that Apple lost 25% of its value. Then I do have in this message, sorry, I forgot to give you this precision. In this message, I do have the current stock price here as a string. Now I want to know the forecasted stock price, and this will take the initial price and add it a random number. Why will this work? Because I have this explanatory doc string here that explains what to do with the function. And let's go. Let's see. Now, I have another array of messages. Now this is weird, but we will see at result 3 that it actually worked. Let's see, let's see. Now, yeah, I think if I put the debugger here, the AI, the LLM did not have the time to define the tool call at this point, but we have it here in our latest breakpoint. The first input, we have here the fact that the stock price is $150, and then we have the tool message. Sorry. Let's see. Sorry. I tried this example before. Okay, the current stock price is 150. I just want to see if I called my forecasting of the stock price. Sorry, let me debug this live. I get top gainers and losers here. Let me check. What was supposed to happen is that I should have called this function, but I didn't see the tool call for this function in my example. And this is why I'm a little surprised, but we are debugging. Let's see. Does it sound like a good image? So let's try again. And let's this time print pretty print a little so we can see what happens better. Let's go. Let's rerun it again. And then in the meantime, I will check the question. What is not clear to me is how the AI model is getting the live trading info updated from the market. To get in 1 hour. Let's say for Apple stock. Also train the AI, we do need to pre-train the between. So I understand your question, JD. The LLM is not aware of the live trading info updated from the market. It's because you define the tool that calls an API to get the live market data that the LLM will be able to use this data in the conversation. Again, also the forecasting stock price part is also another tool that will call another, this time, pure machine learning model that will do prediction based on tabular data. It's not Gemini that will do these predictions. You will use another function, another model that you will design by yourself or with your colleagues to make those predictions. This will not be the LLM job to predict value with numerical data. This will be like traditional machine learning models that will do this job. All you have to do when creating those kind of application is to wire the tools that will allow you to call these systems. One, the stock market API. Two, the model that is supposed to do regression on a price value. But this will not be Gemini that does this job. I don't know if I answer the question, JD. Yeah, it will be a completely different AI model. Exactly. Me, I use Alpha Vantage. I see you use Yahoo Finance. And yeah, Christophe, this is the bug I'm having. The information about current stock price, misleading part of the model. Maybe I've tested it yesterday and it was working just fine, but I guess it's the demo effect. Let's see again what happens here. I send my first input. Then it calls top gainers and loser because I asked the questions. And then it says that Apple lost blah 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 20% of this value and its price is this. Then I ask for the forecasted stock price, and somehow it doesn't manage to get from the previous interaction the stock price. I don't understand why. I must have forgotten something. Let me think. And but we see in the last interaction here, I have something else. In the last interaction here, I have this tool message. Then do we have another one? Yes, here, now we have it. Look, I will try to zoom in. Sorry. We have the first tool message, which is who are the top losers and gainers. And we have the second tool message with the forecasted stock price. That means the tool call worked, but I think it worked by adding a random value to the $150 value. Let's check it out actually by printing what's happening here. Let's print let's print it here. So we are completely sure that our graph actually works. And I was actually sure it was working. So let's try again. Let's go. So yes, I have an initial price of 100, which is wrong because it was supposed to be 150. So yeah, we have a bug here, and I will try to fix it and then share with you the solution via GitHub, because it was supposed to give with the next interaction the forecasted stock price with an input value of 150, but it gave instead 100, maybe because it misunderstood the output here, which is it lost 25% of its value. Its price is 150, and maybe try to do the calculation 150 minus 25%, and then the initial price was 100. I suppose it's that. Actually, let's verify. Apple is top loser. Let's give it less information. Top loser today with it is valued now at, yeah. Let's forget about the 25% reduction. Maybe this is what's yeah, exactly, Alexi. But LLMs are not good at mathematics, which is a known fact. But let's try again. So yeah, now I have the initial price right, because this time I did not give too much heavy mathematics to Gemini, although if it's just a percentage calculation, I just gave it the raw price. So the initial price that was given to the forecast stock price function was correct. And this is a lesson for me too. If you give too much information to a tool output, especially if it's string data and not structured data, you may encounter problems like this. And yeah, keep it short in your tool outputs. I tried to do a scenario here, but with a shorter output, I get better results. And let's go back to what the terminal shows me here. The first tool call is the fact that Apple is the top loser. The additional tool call that I get after that is forecast stock price with the input of initial price of 150, which is the price that was returned here we can verify again with another value, let's say 99, to be absolutely completely sure that the whole logic works as intended. So let's try again. So yeah, I like this workshop format because you get to do debugging live, which is fun, and yeah, sometimes quite stressful. So it says 100 and not 99, and now it completely beats me. Why does it do that? I don't know. I also have run a stock price forecast. So it says to me that it knows that the value is 99, and then later that it has run a stock price forecast of 100. So it must have done some kind of rounding, but you get the idea. The idea is that I've asked for information. I get the output of a first tool, but now I'm frustrated, so I will add another number. I get the output from the first tool. Then I get the output from a second tool with the initial tool result. And then I get the final answer based on the two previous outputs. And we didn't dwell too much on the final answer. And the final answer is here. Now it says to me that it has run the forecasting of the stock price again with the wrong value, but maybe it's just about prompting in the doc blocks, and it tells me that the stock price has a significant potential for growth, blah blah blah, because I've engineered the fact that it will grow up again in my tool outcome. But I think if we just change this here, we get the doc blocks to be more specific, like we did before. Maybe we'll get better results, but we really need to move on with the next modules. What I wanted to do here was to show you basically a series of interactions with different tool calls, and I think we had plenty of that already. Maybe should we add? Oh, Christophe gave me an advice. Maybe should we add some information that the exact stock price is very important? Yeah, exactly. That's what I just said. Maybe we should just in the doc blocks give more precisions about that. And I have another message from. Sorry if I pronounce my pronunciation is not correct. Matt, who's done large languages are not good at that language. Yeah, exactly. Thank you for the citation of Yann Lecun, effectivement. Yes, indeed. So now I would love to debug this more with you guys, but if we spend time on this, we'll not talk about the plan and execute pattern. So I suggest we move on, and I put for my personal reference, a to-do, get a more consistent output by changing the doc blocks. Okay. So yeah, and I will push it in the repo, so you will have the updated code. So don't worry about it. So now we are going to tackle the plan and execute pattern. So how does that work? I think I've also created a slide for this, and let's see, what time is it? Yeah, we still have a little time. So now that we have talked about a very basic React pattern, we want to talk about the plan and execute pattern. So what does this thing do? You have an initial input. The LLM tries an agent, which is the planner, tries to figure out what to do with this initial input. It tries to break down into steps what is necessary to fulfill the user input request. Then it executes the plan step by step. Then when the steps are executed, it reassesses the plan with a replanner to see if we are going in the right direction or not. So it is way more involved than just defining what tools we need and when to call them. This time we are creating a roadmap of steps, and after each step is executed, we are trying to reassess, are we going in the right direction or not? This is what the plan and execute pattern does. It gives more reliable results than the React pattern because it breaks down complex tasks in many steps and it reassesses them. But it's slower and it will consume more tokens, and it will therefore cost you more money to use such patterns. But it can solve more complex problems. This is what you need to understand about this pattern. So let's try to do exactly the same thing than before, which is creating a requirements file. I will go faster this time because you all know the drill now. Okay, I will create my app file and I will install my dependencies. And yeah, sorry about that. Okay, now we have everything installed. I will select the correct interpreter when it's done. And we should be fine. Sorry. Okay. Now we are going to use DuckDuckGo search because we are going to do web searches. And no, we don't need Olama actually. I don't know why I put it in the requirements. We don't need this one because we are not using local models. We will use also Google Gen AI, but we did before with the chat generative model. So yeah, basically, yeah, we'll need async IO. Why? Because we are going to run asynchronous code in our main script. Yeah, thank you, Anna, for answering this question. So now that we have installed our environment, we are going to create this planner step by step. So basically, this example, I took it from the LangChain documentation and adapted it a little to do for Gemini. So you will find all kinds of examples on the LangChain docs, which is basically how I learned LangChain. So the first thing we are going to do is that we are going to design a tool to make search queries on the web. So we'll use something called the DuckDuckGo Search API wrapper from the LangChain community package. We will define for a structured output of queries a class called queries. Sorry, I'm having a little water. So basically, we are going to generate, let's say I'm talking to the model and I say, I want the current gold price. We are going to generate X subqueries for this input. It's like when you are talking to a good old-fashioned search engine, you will generate search engine queries to get the best results you can from this search engine. And what we are going to do is for that, which each user input, we are going to generate several subqueries to maximize our chances of getting the best result from the web. So this is what this class queries does. It's going to generate 3 web search engine queries to answer the initial query. And we create a chain for this. We've already tackled the concept of chain. And this time, the chain will give us back structured output. And we can try this little tool already here. Sorry. We can try this chain already, which basically, from a user input, will generate subqueries. I think this the first introduction of this was from GPT researcher. Let me search the web for this. Yeah, it was this repo that implemented this pattern. I think it was one of the first. I think they have like, this infographic here is great because basically you will have your first input and it will generate query 1, query 2, query 3. Then it will search the web, get all the information that it needs, and then concatenate all the results and then answer back to you. So yeah, let me just share with you this repo, which is a reference in this field. Oh, goodbye, Matsudan. Goodbye. I didn't see the message. So let's see how we generate subqueries now with this example. So what do we have here? We have our queries pydantic model that we have set here. And within the queries, we have different ways of rephrasing my initial input, which was a question here. Now I have 3 web search queries, and this is in order to maximize the fact that when I will look for these queries on DuckDuckGo, I may increase my chances of getting the best result. So yeah, it works. I can generate subqueries. We are at the part of creating the structure for our plan and execute pattern to work. And we decided that we need to look on the web to make this example work. So we start with generating the subqueries. Now that we know how to generate subqueries, let's actually search the web. And we are going to do this with this chain here that I'm going to copy in my script. So this chain, what does it do? It runs this DuckDuckGo wrapper. It runs the query. The query that will be run will not be my initial query. It will be the query that the subquery that I will generate with this chain here. So basically, I will run this tool 3 times at each interaction because I generate 3 web search engine queries. So I add a prompt. What does this prompt say? That we have an initial user query, that we have raw information coming from the 3 different web searches that we have run here. And I say to the model that it is a documentalist, and I give it guidelines, very precise guidelines on how to use this information to answer my query. So I tell it to don't use insufficient or outdated data, etc., etc. So this is the second chain that we'll be using in our graph. It's called search the web chain. It will generate queries, and then it will concatenate the results for each subqueries. I should have called this subqueries because it would have been clearer, but you get the idea. I have the first chain that generates subqueries, which is here, and I will use it to make web searches and actually search the web. So you can, with LangChain, you can use chain within chains, and you can nest them the way you want. It's really, really powerful. And then we have our QA chain, which is the last chain of our web search functionality, will be to summarize all the search results in one response with guidelines. So 3 chains in one, 2 chains in one that I do need to drop off. Okay. Goodbye, Sam. Thank you for following us so far. And this is our first chain that will be used in our pattern. So we can try it. See how it goes. So right now we are not tackling the plan and execute pattern. We are just creating the tools that will be then used by our planner and replanner agent in our graph. So let's go. Let's try the search the web chain now. So what does it say? The top losing blah blah blah. Let's copy the value because it's easier that way. So I do have some kind of a summary of the top losers, but I do not have any actual information. It's probably because when I search the web, I do have like the headlines of the website, but not the actual information, because scrappers and people don't like them. That's why. But basically, my chain works. I do make subqueries, I do search the web, and I do get a result back. Although using just the plain DuckDuckGo API wrapper, you may have bad search results. Maybe you want to use another search API, but DuckDuckGo being free, this is why I used it in this example. So now we have some way of searching the web. We can now put this into a tool, because we are going to have tools in our graph. So let's add this import of tool, because we'll need it. And let's put our search the web tool beneath our decorator here. So let's go. And then we are going, now that we have all the tooling necessary to go on the web, we will design the executor agent, which will be the abstraction that will actually call the tools that we need. So we have three agents. We have the executor, the planner, the replanner. The executor will actually execute the steps of the plan. The planner will plan what we need to do. The replanner will reassess after each step what we need to do. So this one that we're building will be the executor, and it has the tools that we have just created, a simple search the web tool. So let's create our first node, which is a React agent, and we need to, this time you see it's much simpler to create a React agent with the helper function that helps you do just that. So we have our React agent that uses the tools that we have just designed, and we give it a system prompt that tells it that it can search the web if it has to. And now we can give it a spin. Yes, here. I've already set this example here. Let's see if it manages to get current Apple stock price. I hope it does. Let's run it. And now it says that it's 245. Let's see if that's the case. Or is it completely hallucinating? Yeah, it's right. It is indeed 245. So our tool works for certain queries. For some others, because many websites now implement a lot of anti-scrapping features, it will be more difficult. But for general queries like this will work. It will search the web and give you an answer. So what we did here is that we created a web search tool. We've added it to an executor node that will be used in our plan and execute pattern. So far, so good. Now we are going to the planning part. So we know that we have something that can browse the web and answer the user. We want, I remember you that we want to create a pattern that allows us to decompose a complex task in several steps. But for that, we need an abstraction to actually create those steps. And this abstraction will be the planner. So let's create it. We need these imports. Let's go. These imports, which are annotated list, tuple, type dict, and operator. And you see why we need this, because we are going to use known patterns in LangGraph, which is to describe the state that we need in our graph. Basically, what we need here is, what we need here is a state to hold all the steps of our plan. So we'll have the original input of the user, the list of steps, and the steps that were executed before, and finally the final response we give to the user. This operator add thing is the same behavior than the messages state of LangGraph that we've seen before. It just signals that we are going to concatenate past steps within a past steps list. So this is why we do this past steps thing. So this is why we do this operator add thing. It's just to signal in our program that we are going to concatenate steps that were executed and not override them. So now that we have some kind of a state for our planner, we now need to create the actual planner. So we need a prompt template for this. Let's let's put it here and let's create it. So a plan is a list of steps. Well, this is why we create a class for this. We need a prompt that tells the planner what it is going to do. A plan, we have defined it because we are going to use structured output for this. And we have our planner, which is basically a chain containing the prompt and Gemini that is constrained with this kind of output. So what does the system prompt say? It says that for a given objective, we are going to come up with a simple step-by-step plan with individual tasks, and the result of the final step should be the final answer to the query. So let's go. Let's define our planner. Okay, we have now a planner, and let's try it because I love to try at each step. And even if I do, I still have bugs. This is the joy of programming. So now we are able to test our planner. Here, for instance, I give it a more involved query. I asked it to help me build a stocks portfolio, which is kind of a difficult query, even for a human. So let's run this thing. And let's see what kind of steps it will output. So for the query, help me build a balanced stock portfolio, I get these steps. Define the investment goals and risk tolerance, research different technology stocks, determine desired allocation, and so on and so on. These steps are actually pretty good. I should talk to my banker and give it to him. But yeah, my planner works. It gives me steps, and these are the steps that will be executed. How will they be executed? By our executor agent that is equipped with a web search tool. So basically, each of the steps that you see here will be executed by this, and this thing has access to a web search. So what is the missing link in our plan and execute pattern? We now need to define our replanner, which is the thing that will assess if things were going right after each step and recreate, if required, a new plan based on the execution of the previous steps. So let's go with the replanner part. This is actually, it's not technically necessary to create a replanner, but it will make your application way more robust if you do than if you don't. So let's use the union type because we will need it, and you will see why in a second. So let's just copy the code and then I'll explain it to you. So I will need for my replanner, I will need two things. The final response to the user. Let me format this better. Yes, the final response to the user and an action to perform. So the replanner has two possible outputs. Either it thinks that we have reached a point where we can give a final answer to the user, or it can give you another plan, because as the graph is executed, it found out that we are not going in the right direction. So it outputs a plan again, either the same plan or a new one. So we describe what the act class is, which is an action to perform, just what I said, either the response to the user or the fact that we'll need to go over the plan again. And we feed our replanner with this prompt that reminds it of the initial objective, the original plan, the completed steps at the time it was called, and then some instructions that are really important. Now, for this kind of patterns, you need to be very careful with your prompt engineering skills, because it will have big incidence on the robustness of your graph. So the instruction here, we say to the model that if more steps are required after we have executed some of them to achieve the initial objective, you will need to return a new plan with the remaining steps, or you can respond. And we tell it to never return an empty plan, because otherwise we will have a buggy application, and we don't want that. So we also enforce the structured output part. I don't think that's necessary now that we have these helper functions. But yeah, I feel more safe keeping it, so I keep it. So we also tell it to remember what the different Pydantic classes contain. So we are very, very directive and explicit on what the replanner does, because it's a central piece of our pattern, because it's the thing that will give the final answer to the user in the end, according to our little schema, which is here. This thing will either give the plan back to the agent again, or give the final answer to the user. This is why, because it's public facing, this is why we need to be so careful with our prompt here. So where were we? We were at the replanner steps. Yep. Now we can put all our three pieces together, the executor, the planner, and the replanner, in our graph. So let's do that now. It's going to be quite heavy, but given the powerful feature we're building, a simple script of less than 200 lines of code, I think it's extraordinary, actually. So yeah. So LangGraph graph import end. This is basically a constant that says when we need to stop the execution of the graph. And let me explain the code that I'm pasting here. So these are basically the nodes of our graph. There is a step execution node that will take in the plan and executed state that we've defined before. This will actually allow an agent, the executor, to invoke each step of the plan, which is called a task. So we masquerade it as a user message, but actually it's the AI will use a task created by AI and make it sound like it's a human message. It's not actually a human message. It's one of the steps of the plan that will be executed and maybe trigger a web search, the web search that we've defined before. So the execute step will return, will add to the past steps the outcome of the executions so that the replanner knows if it can give the final answer to the user or not. The plan step is the first step in our logic. Let me show you the graph again. It's the first step in our planner logic. It will tell the whole system what steps we need to execute. So it's our entry point. And we have the replan step, which is in charge of giving the final answer to the user or not. So I think I have a copy-paste error here. Sorry. Let's go. Yeah, forgot this. So the replanner step is the thing that will decide if we answer the final answer to the user or go back to the plan. And we have the should end, which will be useful in our conditional edge later, as you will see. So now we are ready to build our graph. So now that we have specified that we need end, we specified that we are building a stateful graph that has a start as well, and we can compile this graph before using it. So the three nodes, as I said before, the planner, the agent, the replanner, and the edges between them, it's really sequential in this pattern. There is not much of a loop besides between the replanner and the agent. So we start with the planner. The planner gives the step to the agent. The agent is basically the executor. We can call it the executor. It will be the same. The agent we then call the replanner, and the replanner will decide with the function should end if we send back the interaction to the agent or if we just answer to the user. And the fact that we should end or not lies in the fact that we have a state response value here. So now that we have compiled our graph, we are ready to use it. This is why I use in async IO, so I can use asynchronous code directly in my main script. Let me import it. Here. Okay. So let's try it. So what do I do here before we try? I ask it between the recent top losers in the stock market, and this will trigger a web search to give me the one that will probably go up again in the near future. And I ask it to not overthink it. Otherwise, I would like have hundreds of steps, and I don't want that because yeah, it consumes a lot of tokens, and it's already 6:30 soon, so we make it short. So let's go. I will have all the different steps of the execution of the graph printed, and we can see them here. So first entry point is the planning part. List the recent top losers, select one from the list, and explain the reasoning. Basically, what it did, it has like, oh, I have a list index out of range here, but it's okay. We can still look into the output here. So basically, it took my initial prompt and created two steps out of it. List the recent top losers, select one from the list that is likely to go up again. And as a reminder, my prompt asked it to get the top losers and the one that will go up again. So basically, just split my prompt into two and created those steps. So in the past steps, it has listed the recent top losers in the stock market, and we can see that it has done a web search here. And now, after running a few steps, it knows that it has this step to do, this remaining step to do. So before it had two steps, now it has one. And now the past steps contain two outputs when it contained only one before. You can see that we execute a step of the plan, it feeds the past steps array, we execute another steps, and the past steps is incremented with one output. Now we have a new plan that is the job of the replanner. The replanner took the previous values, which are the top losers that have been found by the web search, and it tells that it will try to select the one that is likely to go up again in the near future. Now, it knows that it has these past steps, and now it gives me an output that is very, very coherent, which is that given the recent top losers, it selected this one, Wingstop Restaurants, because although the stock dropped, analysts still have a buy rating. So it explains the reasoning because I asked it in the prompt based on the steps it has executed before. And the last bug I had is because now that all the plan has been executed and that I have no past steps, that I have no new plan to go through again, then it has crashed because instead of giving me a final response, it tried to replan again for some reason. But I do have all the steps executed and frankly, a quite good looking answer. So the probable cause of the bug happened. This is why I said the prompt here is very important. Probably happened here because the plan contained a list, an empty list of steps, since every step has been run, but somehow we went through the planner again and it crashed. So where does that happen? Not here, sorry. Let me just look for the place. Yeah, here. It crashed exactly here because we passed it an empty array of steps, so it didn't find the first step. That's why. This is easily solvable. And what I want you to take with you now is that we have executed steps and we got the result of the past steps. And when we crashed, it's because we didn't route to the correct final response for some reason. But let's try with another prompt maybe. And yeah, let's try something else. I don't know. Given the reaction to, I don't know, COVID-19, how will gold price be affected in case of a new pandemic? Okay, let's try this and let's see if we'll have the same bug again. Again, this is very frustrating because when I've set up this workshop, everything was running fine. But I love demo effects and I love live debugging. So yeah. So now what do we have? We have a plan that is quite big this time. We have lots of steps and yet the same error again. I need to understand why does it go to execute step when it should not. I think I forgot something. But yeah, again, I will commit in the repo the correction of this. I think I forgot the go-to parts. Sorry, go-to, no. It's okay. It's okay. We know why it bugs. It's because it passes an empty array. But I think we can fix this quite easily. If state plan is, maybe we can try this here. If state plan or blah blah blah, we end the interaction. Maybe this could solve our problem. If it doesn't, it's okay. I will try to fix it on my own time and update the repo so we can have the solution. But what is impressive here is that we had a lot of steps described to assess how a new pandemic would affect the gold price. We have a lot of past steps that are described because we made search queries with this. The initial plan did not change much at first, but we do have a lot of content that is produced following these steps with reasoning explained uh, at the end of the output. But what should have happened is that all these conclusions should have been brought back to the user, but somehow we have passed an empty plan again to the executor. This is why we have the bug. Yes, Alexi, I will indeed update the repo because I will make it more robust, I think. So now that we have added this, let's see if we have the same bug. And if we do, I'll try to solve it on my own time and update you guys with the results. So will it understand that it should not? Yeah, we have an empty plan here. And we called end, so this did not crash, but we did not get the final answer. So maybe we need to change our graph a little. We need to pass it to the, you know what? Let's create a new prompt, a summarizer prompt. Yeah, let's create a new node actually. So summarizer. Yeah, let's create a new prompt. Let's do this. Let's do this live. So chat prompt template. So what we need is a template that has an input. Giving you a to plan that on the output. Now it's going to take too much time. But what I wanted to do is here, and this is the commit that I will push later on. What I wanted to do is that when we reach end, as we did here with an empty plan, then I take all the previous messages and pass them to a new node that I will call summarizer, and that will summarize the results of all the steps that have been executed, so we can give a decent final answer to the user. So yeah, I will update you with this, but you get the idea. So what we have seen here with the plan and execute pattern is that we can prompt an LLM to decompose a complex query into several steps, re-execute them, and add that to the state of the graph to do something with it later. So that's for the plan and execute. I don't know, Anna, do you wish to continue? Because it's already 6:30. We do have one module left, but I don't know if that's too much or not. What do you think?
Um, just depend of your feelings. Are you tired or not? Because I worry that you are tired at all.
Actually, yeah, I think it's a lot for one session. Maybe we can replan this for another time where we can start directly with module 5 and then go on with other modules for a next session, because otherwise it will be too much of a session, and I'm afraid we are going to lose everyone, including me. So yeah, maybe we should start a next session another day, starting from step 5 and so on, and with the bugs corrected from this session. And I have a lot of questions, so yeah, let's do a Q&A session. Thank you, JD. Thank you. That's really appreciate. I'm really sorry about the bugs you encountered, because when I ran all this code yesterday, it was running just fine. But thank you for the comment of appreciation. Um, do I have some contact info? Yes, yes, of course. Let me share with you my LinkedIn. Sorry. Um, and then And I have a question in French from François, who asks if it's possible with scrapers to transform unstructured data into structured data. Yes, François, it's totally possible. This is why applications like Firecrawl are really, really, really popular today. Let me show you. This is basically what they do. They will scrape websites, turn them into structured outputs, and allow you to consume it via their APIs. They have tons of adapters and so on. So it is a really good application, but like every application, it has a pricing, and you can build it yourself. So it's your call. You can build your own agents that scrape the web, get structured output, and then you do whatever you want with the JSONs. So yeah, that's for François' question. Felipe, yeah, yeah, I know. We'll start from module 5, and I have hopefully bugs will be solved. Thank you, Alexi. Thank you very much. And thank you, everyone, as well as Christophe. Do I have another question? I don't think so. Um, do I have any background in experience in ML? Yes, I did work one time with computer vision. I trained a PyTorch model for OCR because our client required to parse handwritten documents. This was my professional experience with ML, but ML is not my main focus. I'm mostly a web applications developer. Yeah, so I do have a little experience in ML, but I'm no expert. And thank you very much, guys. I think we have no further questions.
I think you answered all questions during this workshop.
Oh,
So
sorry.
I think we haven't other questions, and you
Yes,
answered all questions during your workshop.
great.
So it
Oh, I
was
think Christoph
amazing.
has one quick
Real,
questions. Yes, yes, go on, Christoph.
real life coding workshop and checking chat. It was amazing from your side.
Yeah, yeah, yeah.
So, okay, this brings us to the end of today's workshop. Yes, and thank you all for your participation and for your active participation today. And a very special thank you, Yacine, for your really
Thank you.
insightful presentation, a workshop, real life coding, debugging. Thanks for sharing your valuable knowledge with us. Really, it was impressive workshop.
Thank you
You
very much.
very detailed explanation of hard things and your examples, amazing examples. So this session was recorded and will be available on YouTube channel, so everyone can watch one more time and share with friends this amazing workshop. Please don't forget to submit the post-event feedback form because your insight help us improve and make future sessions even better. Once again, thank you for joining. We're looking forward to seeing you in our next sessions. I
Yes,
hope to see
with
you
pleasure.
soon online and in person. So
Thank
until
you.
then,
Thank you.
keep learning, experimenting, and build with AI.
Thank you. Goodbye.
Bye bye.